Okay, so we are using Hess's law to find enthalpy, so still delta H, but we are going to use it to find the enthalpy change a different way. So there are many reactions that we obviously can't do in a coffee cup, okay? Um, so we're going to actually, sort of reach the limits today. We're going to use we're going to do a reaction that is um, like I said, like 30-ish degrees Celsius for the temperature change. So that's about as much as we can do, really, in a coffee cup. So there has to be another way that we can find how much energy is either lost or absorbed in a reaction. So Hess's law, named after a person, Germain Hess, who was the first one to describe it, and it makes a lot of sense. If you have reactions that can be combined to make some sort of bigger overall reaction, then if you can combine the reactants and products, you should be able to do the same thing with their energy values. So the enthalpy change, whether it's physical, chemical, doesn't matter, only on the beginning conditions and the end conditions. So again, we're looking for the net change, not really what happens in the middle. And it's independent of the pathway and the number of intermediate steps. So this is the first introduction to, unless you've taken biology, to something called a mechanism. That there are many reactions that actually don't occur just as one step like you're used to. A lot of reactions and the ones inside our body, biochemical reactions, are very complicated. They have a mechanism or more than one step. Usually in chemistry, just because of chemical loss and like the nature of things, usually there's only about, most questions have 3 steps. Sometimes you'll get 4, but usually 2 or 3. And we'll talk about in the next unit uh, when a mechanism is reasonable and how do you decide um, whether the mechanism you're proposing is reasonable. But in this case, when we do Hess's law, we're just going to use the steps that you're given. So these questions are good because you have to be given reference information. And then we're going to combine that reference information based, maybe we have to flip it around, maybe we have to do stoichiometry and manipulate the coefficients, and then we get the reaction we want and do the same changes and add the enthalpy values. So it's kind of like a puzzle. You know what you want the end to look like. You just have to get it there, okay? And these questions are very obvious. Even if it doesn't say, which I really try to, using Hess's law, etc., you'll be given a list of steps. So, and it's what's called a target reaction. So they look very different from what we've been doing before. But it's going to get us the same delta H answer. So if you've never, or if you haven't dealt too much with sequences, then That's Greek symbol is sigma. It means sum of. So the very technical definition of this is, like I said, we call it the target. What's the enthalpy change for our target reaction based on adding together different enthalpies of known reactions? So you can determine the energy of a chemical reaction without actually doing the reaction. So today we are going to find the enthalpy of combustion of magnesium without actually burning it, which is good because you can imagine burning magnesium inside your coffee cup calorimeter is not, I would not call that safe. Okay, so when you combine chemical reactions, what kind of math are you going to do? So there are two rules we have to follow. So we're going to, the Hess's law, the pathway we get there is independent. It doesn't matter. However, you can't, we have to follow some rules. We are going to add the equations with known enthalpy changes. If we have to manipulate the equation, then you just have to make sure you follow, there's only two rules for the algebra. Okay, so the two rules we have to follow if we are going to reverse a chemical reaction. So what that means is we're going to take the products that are written like you're used to, we're going to write them as the reactants and the reactants as the products. Then if the delta H is negative, you have to change it to positive, which makes sense. It's basically like you're switching whether it's endo or exothermic. And then this we've sort of already also talked about. If you're going to change the chemical coefficients to make it fit your puzzle, your target, then whatever you do, you have to, it's like math. What you do to one thing, you have to do to them all. So if you're going to multiply one substance by 2, everything has to be multiplied by 2, including the delta H, okay? So don't make annoying mistakes where you figure out the puzzle, you get everything to work out, and then you forget to change the delta H values. That's like the easiest part, okay? So don't forget to do that because you'll be mad at yourself. Okay, so let's do an example. So determine the enthalpy change for the reaction. So you're given a reaction. We're trying to find what its enthalpy change is. This little knot here means standard. Don't worry about it. That doesn't affect anything. But if you see that there, it just means delta H. So you're given a target. So this is the enthalpy change that we're looking for. But then you have to be given known values. So given the following reference equations, so you'll always be given them, except there's one question in the review that makes you write them all. It really is a good question, but it is tricky. So you're given an equation that has similarities to the target. You're given the delta H value, but it's not exactly the same. So we are going to make it fit. So the way that we handle this, and there's a reason that I wrote these arrows lined up like this, and there's a space here, because what you're going to do is cross out substances that are found on either side or both sides of the equation. So if you line up your arrows, then it's a little bit more obvious what are products and what are reactants. It's sort of like they cancel out, okay? So, for example, here, hydrogen is a product. Over in step number 2, it's a reactant. Those are opposite sides. So you can cross them out. And if you take a look at the target, do we want hydrogen in our target reaction? Is it up here? H2? Nope. So we had to cross it out. We want H2O2. Is it in the target? Yes? We don't want to cross it out. But then we have to do something about this oxygen and this oxygen. So if you look at the target, is there oxygen on the reactant side? No. So we don't want it. However, there is oxygen on the product side. Okay? We have oxygen here and oxygen here. So that means that if we've done everything correctly, which we didn't have any to make any changes here, this is very, very easy. So it should work out. So it's like canceling or subtracting. If you have half an O2 here, but there's no number here, what's understood? 1. So if you cancel half an O2 over here, how many would be left? Half. Is that what we want? Yes. So it has to work out. If it doesn't work out, then you have made a mistake, okay? So again, it is kind of like a puzzle. You know what you want your answer to look like. You just have to get it there. So now it's going to be like we're in grade 3. And we're going to, everything's in a column. And we're going to add up the columns. So what's left on the reactant side? H2O2 only. Is that what we want? Yes. Let's see. On this side, what's left? H2O, good. Half an O2, good. And then don't forget, we also have to do this. Positive 188 plus negative 286. Sorry that I wrote it way at the bottom. So don't do all this canceling out and forget to add these together, okay? Like I said, that's a very annoying mistake to make. You've done all the hard stuff. Don't forget to do what's easy. So the next example we're going to do has more. We're going to have to change the equations. It's not going to be this straightforward. And we're also actually going to have to do stoichiometry. So I left the example like it appears in your textbook. If this were a test or a quiz, it would say, Part A, using Hess's law, find the molar enthalpy of I think I stick with zinc sulfide. I don't know why I'm so obsessed with it. Yes, combustion of zinc sulfide. And then it would say part B, if you have 50 grams, blah, 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 but your textbook combines it. So I left the example combined, okay? So these questions, if you do the first two, eventually, if you want to wait till after tomorrow's quiz, that's fine. This is on D2L as well. If you do the first two and that's it, then that really is limiting how difficult the questions are. They get progressively more difficult, okay? So I recommend that if you do one of these and you're like, this is too easy, even skip down to these, okay? Because the puzzle can be a little bit, get a little bit crazy. Okay, so this question, it wants you to, you're given the equations, and it also says 50 grams. So I left the question like that because that's what your textbook does. That's not his one. But for us, I promise that I will split it up, okay? Part A, do Hess's Law. Part B, then it would say 50 grams. But those questions on page 329, your textbook puts it together. So most people will do the Hess's Law and they think they've gotten the wrong answer, but that's because you have to do Stoic as well, okay? So we're going to do the example like leaving it like the textbook wants. While you write that down. Grab the acid. So the biggest complaint about Hess's Law that students have is you'll get a question like this. There is a target, and you're given steps, and students will say, Miss Todd, I don't even know where to start. Okay? So what I recommend that you do is, first of all, look at each step separately. Okay? So if you have to make changes to the steps, or the intermediates, or we're going to call them elementary processes later. If you have to make a change to the step, you don't have to make the same change to step 1, 2, and 3. Just within step 1, you have to make the same change. Okay? So if you focus your mind on the first step and then look at the second step, don't try to do it all at once, then that might be a little bit more straightforward. Okay? So step number 1 has zinc oxide, zinc, and oxygen. So maybe your eyes are drawn to the zinc. Do we want zinc in our target? Is it in here? Zinc by itself? No. Oxygen is in our target, but it's on the wrong side. It has the wrong coefficient. But the problem with oxygen is it's also in step number 2. Okay? So that can screw things up. So what I would do is focus on the zinc oxide. Is zinc oxide in the target? Yes. Is it anywhere else in any of these steps? No. So whatever change we make to the zinc oxide has to make it look like the target. Something like oxygen, which is in more than one step, if we make this change correctly, the oxygen should work out. If it doesn't, then you've made a mistake somewhere else, okay? So focus on this because it's only in this step once. Because I don't want to change the slide yet, I'm just going to erase this, but you guys can just keep going, okay? So, what are we going to do? You have to check two things. Is it on the right side of the correct side of the arrow? Does it have the correct coefficient? So here, is the zinc oxide on the correct side? No, it's a reactant, it needs to be a product. Does it have the correct coefficient? No, it needs to have a 2. Okay, so most people are usually good with the 2. We're going to multiply by 2. Now, when it's on the wrong side, we can reverse it. That's easy to do. But when you have to flip an equation, then you have to change the sign of this. Mathematically, what's the easiest way to do that? Multiply by a negative. Okay? So I'm going to flip it or reverse it, and I'm going to change the coefficient. And what I do to 1, I can't just multiply this by 2. You have to do them all. Multiply this by 2, multiply this by 2, and multiply this by 2. I really recommend that you write the equation with the changes. Don't try to leave it on there and change it there. Just rewrite it. These questions take up a lot of geography. I have some paper if you want. I'm sure if you went to your guardians and said, I need some more paper to do my Hess Law questions, I think they'll get you some, okay? Don't squish. Write it all out so that you can easily see how to cross things out, okay? So I'm going to reverse it, I'm going to flip it, and multiply by 2. When you do these questions, you don't have to worry about the solid, gas, liquid, okay? Don't worry about that. So if you don't want to rewrite those, you don't have to. I recommend that you keep the numbers, again, just for organization, okay? So I'm going to put this now on the reactant side and multiply by 2. Okay, so yes, there can be fractions. If you have a half and you multiply by 2, what happens to the 2's? Like you're doing this. You either think of it like 2 over 2, which is 1, or the 2's cancel. I'm going to write the 1 just to emphasize that. And now we're going to put this on the product side with a 2. And I'm going to make the appropriate change. So this was positive, now it's negative, and I multiplied by 2. Okay? Now I'm going to look at step number 2 independently. It does not need to have the same change as number 1. Can it? Yes. Could there be no change? Yes. Okay? So again, sulfur is here in step 2. Here it is in step 3. I don't like that. Oxygen, here it is here. Here it is here. I don't like that. Is SO2 in the target? Is SO2 in the target? Yes. Is it anywhere else in these steps? No. So I am going to focus on this. Okay? So what do I need to do? Check 2 things. Is it on the correct side of the arrow? This time we're good. Product, product. Does it have the correct coefficient? No. So this time we are just going to multiply by 2. Not negative 2, because we don't have to flip it around. And now I have to squish, sorry. Yes. We can, but we have to make changes down here too. So I recommend you make all your changes and then you cross. Okay? Mm-hmm. Mm-hmm. Now let's just pause for a second. Look at the oxygens. Is it going to work out? Yes. And we didn't think of any changes related to oxygen. Okay? So focus on the substances that are only in the steps once. Okay? So then the last one here, number 3, check 2 things. So zinc, I don't like that. Sulfur, I don't like that. We're going to focus on this, zinc sulfide. Is it on the correct side? Yes. Does it have the correct coefficient? Nope. It needs to multiply by 2. I am going to line up the arrows so that I can clearly see what's a product and what's a reactant. And now we're ready to cross stuff out. So when you go to cross stuff out, just in case you've made a mistake, don't be a maniac, okay? Just lightly cross it out so you can still sort of see what's underneath. And remember, whatever we cross out should not be in the target, so we want to get rid of it, okay? For example, zinc. Do we want zinc in the target? No. So look for the substance that can cross it out. Zinc, here is a reactant, here it's a product, cross it out. Oxygen on the same side. So remember, you got to think like you're in grade 3 again. You've lined it up. We're just going to add those together later. What else? 2 sulfur reactant, 2 sulfur product. We don't want sulfur in the target. Cross it out. So what are we left with? 2 zinc sulfide. Do we want that? Yes. We want 1 plus 2, 3 oxygens. Yes. It doesn't really matter which one you write first, but if you want to keep it exactly the same as the target, let's write the zinc oxide first. And the sulfur dioxide. And then just don't forget to add these together, keeping these two negative, like negative 701 plus negative 593.6 plus 412 is negative 882.6 kilojoules. Don't forget units. There should be units given to you, so just include those. Yes, Katie. And then Maria. Yes, because this is the only step that I had to reverse. See how these are the reactants and now they're the products? Because I want it to be on the product side. So if you flip it around, you change the sign. Okay? Yes, Maria. No. And you don't even when you rewrite it? No. Yeah. On a test or quiz, I probably wouldn't even give them to you, but they're in your textbook. Okay? So most of the time, this is it, you're done. But again, this question says 50 grams. So this, if this was us, this would be part A. And then part B would be the stoic. But like I said, on page 329, you have it just clumps it all together. Okay? So sometimes students are like, Miss Todd, I think I got it right, but I didn't get the right answer because you haven't done the stoic yet. Okay? It's just a little bit annoying. So we're going to do the same thing like we did before. I don't want to squish, so I'm going to make a new slide. Here we go. Again, I don't really know why both of these examples are zinc sulfide. I have no, I have no idea. It literally could be anything. Okay, so please don't think like that. So we have to find, just like before, you have to find moles. One zinc is 65.39. That's 3206. Okay, so we're going to do the same thing, same story. How many kilojoules for 0.513 moles of zinc sulfide? And then usually you have to use your answer from A. So we found the reactions value was 882.6 for how many moles of zinc sulfide? What's in the reaction? Good. Okay, decide what you like, cross multiply, do this divided by this times 0.513. And again, now we have way less than 2, so our number should decrease. Yes. Good luck. When you've got that down, you need the sheet that you picked up this morning. It says Hess's Law Lab, please. Look at your lab sheet, please. Okay, so one person in your group at least needs to have a textbook. That's where the procedure is, okay? And what you're going to be doing is you're going to be using magnesium ribbon, which I put sort of beside Lauren and Jamie. So you need one piece of that. And then the other reaction is going to be magnesium oxide, is a powder. So for the powder one, you're going to follow the same procedure. One person wear the gloves, get a little beaker, tear it, etc. If you want, if you're going to use your same little beakers from this morning and they're still wet, I don't recommend that. I think we have zillions of beakers. Just get a different one, okay? Because, or really, really dry it out because the stuff will stick to it. It's pretty powdery, okay? So what you're going to do is you're basically going to use a calorimeter. And there's two reactions, Mg ribbon, MgO powder. It is not the same amount for both. So maybe you saw me cutting the little strips. I made the strip approximately 0.5 grams. Make sure you reweigh it. Don't trust me, okay? If it's a little bit more, that's fine, but like even like 0.7 grams, it'll be too much, okay? Don't, like the temperature change will be too much. So just let me know and I'll come cut it for you, okay? You want to kind of coil it, not super tight, okay? But it needs to fit inside your cups. And this time inside the cups is going to be 100 milliliters of hydrochloric acid. So you need to make sure that you wear goggles this time. What I'm going to do, the beaker that you have at your station that has distilled water in it, just pour the distilled water out. I will come and pour some hydrochloric acid for you, okay? Both reactions are going to use hydrochloric acid as the aqueous solution side. So if you happen to look at the practice quiz, I only put one calorimeter question on there. It's a solid system. But remember, we did two where one was a solution. So this lab actually practices that math, okay? So you put it in, you do the same thing, close the lid, measure the temperature change. Measure the acid first. You need an initial, and then put it together, okay? This time, be very careful not to spill. If you do spill, please let me know, and I'll come help you clean it up, because if you wipe up the acid, then you could get acid on your hands, okay? 100 milliliters is a lot of acid, so you need to be really careful today, or this one, okay? Then I'm going to get a waste jug, and you're going to pour the waste. Don't pour it down the drain. We're going to put this waste in a waste jug. And then you're going to reuse the calorimeter. So you're going to get a huge temperature change for the first reaction. When you open it up, the magnesium ribbon should be gone. So you don't even need to rinse it out, really, because the second reaction, you're going to use hydrochloric acid again, but it's up to you. And then you're going to use this MgO powder. So with the MgO powder, you need 1 gram. So again, just to minimize extra waste, the person who does the scale, measure the magnesium ribbon, and you can do the MgO at the same time. But the Mg ribbon is 0.5 grams. The MgO powder is 1 gram. So you definitely need a textbook, okay? Yes. Probably not. And you'll be like, whoa, Miss Todd, this is awesome. So yeah, you probably don't have to stir. Even with this, you probably don't have to stir, but you can gently. But the ribbon one, you should get a huge temperature change. It should be fine, okay? It's really tempting to look and see if your ribbon's gone. Just let it go, okay, as best you can. So then, if you look at the calculations, it says complete C, use delta H system equals negative Q surrounding. So as soon as you have a calorimeter, you have to use the calorimeter equation to solve for delta H. And then you're going to do Hess's Law. So this lab actually has all the math, okay? If you look at the pre-lab number 2, it says to write out the reactions in the introduction. And you can see at the side, it says delta H equals question mark. So there are 2 question marks. You're going to find 2 delta H values. The third reaction is the water one. So we do need H2 and O2, but that reaction, you have to pass a current through water to get them to split. So again, we're obviously not going to do that in our coffee cups. So that value is given to you. You can see it there, okay? So you're going to do 2, the 2 question marks. And then the third one's given to you, and then you do Hess's Law, okay? So it's up to you. If you would like to just get the data today, that's fine. If you want to get the data and do calculations number 1, because that's calorimeter, which is on the quiz tomorrow, that's fine. It's really up to you, okay? So really with this one, like I said, please wear goggles on your face. We do kind of need to sort of work in waves again, but you guys did a good job. So let's just do the same thing. We'll start at the back. Pick one person to be the scaler using the gloves, so we don't have a huge garbage can full of gloves. But you need to come get the ribbon from up here. Ooh, sorry. Yes, if you can tolerate it, I would, okay? Sorry, Michaela. Do you need me or a punch? It's like a spider in here. Okay, use your class time wisely. Study for tomorrow's quiz. Work on this morning's lab. Okay, so this, save that, because that's going to be your accepted. So you use your data and solve for that. So don't use that in there. I know, but that's for down here. So you're going to get an experimental value and compare it to the accepted. Yes, and just solve. That's what you're solving for. Okay. I would say Friday, like after the test is okay. Yes. Now this math is on tomorrow's quiz, so if you're good, you're good. You decide how you want to study. Yes. I just have to